Alright, sorry I'm back to using the old computer that has the scratchy microphone, so sorry if this is a little scratchy. I tried to minimize it as much as I could, but I had no other option but to use this computer today. Alright, so here I have the COVID-19 that was sequenced here in Texas. It was a version that was found only here in Texas, and they sequenced it here at the medical center. And so I've been searching myself using an entire line, which is 70 letters. And you know, it's really hard to get any hits. And so I reduced the size of the sequence, and so I'm going to suggest for you guys, maybe you can alter this so that you get some results, is to use a much smaller piece of sequence. Keep it at 10. Just find 10 smaller pieces of sequence. They don't have to be contiguous. Do a few at the beginning, a few at the end, a few in the middle, and you don't have to do the whole sequence. And hopefully this will allow you to get some hits. Now here I just arbitrarily grabbed a piece here and I put it into the NCBI. So I have put it in here. Now notice that I have stayed with the standard database. I excluded viruses, plants, bacteria, and the synthetic constructs, and I put it on somewhat similar blast in. And I'm going to run the blast for this, so just look at the parameters I set like we were doing in class, and make sure you exclude these, and I said somewhat similar, and so they don't have to be exact, and I used a much smaller piece of sequence. And so in your case, when you go to pull your gene, use a smaller sequence. I think this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, 17, 18, 19, 20. This is about 25, so it's pretty short. The algorithm in BLAST is different when they're this short, but you can get it to work with somewhat similar sequences. It will adjust for you. And so I'm just going to hit BLAST after this, and we're going to wait here a second. Hopefully it doesn't take too long. Notice it says your search parameters were adjusted to search for a short input sequence. And so it did that for me, using only about 25 letters instead of 70 as we had. So these are obviously far enough apart that we have to get pretty small for you to get any results. I tried it all around the genome and rarely got results. So if you use some shorter sequences, kind of all over, you don't have to use the entire sequence then. Just grab some small 20 to 30 base pairs at different parts and then run it like I did, and you should get something. Now notice you still get these cloning vectors and reverse. That's not what we want. But here we get something interesting. Canis lupus familiaris. That's a dog. Labrador Retriever specifically, and we found a piece. Now here it's telling you where it is on the chromosome, but we would like to know what is the actual gene, and that's going to be down here. So this is in Canis lupus. This is a predicted gene. It means that they aren't certain that this is a gene. It's just that the bioinformatics says it's a gene. They've just never seen that transcript or that protein in the dog. So, or this is Apis florea. I don't know what this is. So you can report that the sequence here is in the dog, but it doesn't look like it's necessarily a gene. It's just that the sequence was found in the chromosome. But here it looks like they have a predicted gene. So I'm going to click on the predicted gene here, and we're going to go see what this is. Now you can see it's not perfect. Not close to it, but it does have some sequence similarity with these. Let me go back. Come on, go back. Okay. So now we have this transcript variant. Now one way to see what this variant is to go over here to the accession. Now it does have 100% similarity. All right, for that size, it coverages 80% of the sequence and has an e-value of only 0.34. That is not very good. These up here, even the synthetics and the vectors are not really that good. But let's go ahead and look and just see what's going on here. What is this? This is guanine nucleotide releasing factor. Now, I don't know what guanine releasing factor is, but obviously it releases a guanine somewhere, and it's a particular variant. It's an mRNA. So this is interesting, and the thing we're looking for, of course, is what's the organism? Apis florea, and I don't know what that is, but we can click there, and it's a honeybee, which might make sense. You get stung by a honeybee, maybe you get the some blood transferred, but I thought honeybees died usually when they bit you. So this, it really doesn't make any sense. So interesting that this comes from the honeybee. All right, so, and it's whatever the guanine releasing factor is. So how would I write this down? Well, for your report, I'm going to open a page here, and I'll put my sequence in. So I want to cut and paste my sequence. All right, so edit, copy. All right, and of course, tell me what your gene is, but here's your sequence. So put your name and everything and what sequences you had, and specifically what sequence you had. And then we're going to report that it was this. So I'm going to grab the title here. More or less. Let's see if I can grab that. Yeah, there we go. I'm going to grab it that way. There are other ways you could tell me this material, but I do want to know the organism right here. All right, and I kind of like it that it's telling me it's predicted. And then here's the name of it. So it's guanine nucleotide releasing factor. All right, and then we want to know the e-value. And the e-value was really rotten, but you know, 0.34 here for the e-value. So let me put that in here. All right, and you've got one done. Now, how are we going to deal with this having to use the smaller sequences? Well, let's go up here. I have NSP1 kind of isolated here from the rest of my sequence. And we've tried, in fact, we tried in class with NSP1 and got almost nothing. So we're just going to have to take some smaller sequences. So I'm going to do it again with NSP1, and I'm going to take a much smaller sequence, like right there. And I'll do it. So you should probably take, you know, 2 or 3 here in the early part, and then, but grab 10 across the sequence. Any 10, they do not have to overlap. In fact, probably shouldn't. And so just go through and grab some smaller sequences and run them just like we did here. So I'm going to run another one. We're going to erase this one. All right. And I'm going to put in this piece from NSP1. All right, we'll run it with the exact same parameters, and we'll see if we get anything. And hopefully it doesn't take forever to search. Now, knowing that this is NSP1 should help us. Hopefully this will give us NSP1 in a specific organism. soon, I hope. Here we go. So of course, don't worry about these early ones. So what is this? So what organism is this? Purus Rapae. I don't know what that is. We'll have to check. Of course, we get SARS. Purus Nappy. So whatever this organism is, I'm not familiar with it. We also get here some other organisms. So now we're getting something. Not a lot, but we're getting something. So let's check out what this organism is. I'm going to go over here. Alright, and the organism, Purus Rapae, cabbage, white cabbage. I thought I said not to include plants. I might have to go back and check that. But let's open this up. But yeah, white cabbage. As far as I know, white cabbage is a plant. So it shouldn't have grabbed this. But oh, here's that was the previous one. All right, so let's close this. Let me see if I can see if I didn't I did this wrong and allowed plants to be. No, it says exclude plants. Well, I don't like that it gave us the white cabbage. That's the other one. Even though I said exclude plants. Let's do it again. Like I said, I'm not sure what's up with this database. We excluded plants and still got the white cabbage. Let's run this again. And you can report that. If it tells you that it's white cabbage, go ahead and report it. But let's see if we can find anything more interesting, like an SP1 in any organism. Alright, so we're going to take a look at this a second time, and we're going to look at down a little further and see if we can find some other organisms that are more interesting than white cabbage. Alright, so I'll check out this Purus Rapae, but we've already kind of figured out that that's cabbage. Alright, I do not know what these two organisms are. We'll have to check those out. Alright, here, Ovis can. So there are some other organisms in here for us to use. Now, what is the E-value? The E-value is still horrible. Oh, it's a whole number. It should be smaller. But, you know, you've only got so much uncharacterized. So let's see what this one is. What we're finding out here is that these viruses are not like anything else. Bony fishes. Okay. Well, report that, as I showed. This will be how you can do this. I have a feeling this isn't going to be very useful, but it's your assignment, learning to use BLAST. So, if you have problems, email me. And nothing is something in this. Make sure you do something like this in your report.